Hello, scholars. I hope all is well with you. So we're going to finish up section 13.1 on trig identities. Before we get into the last example that we needed to go through, let's quickly look back at where we went. So when we look at fundamental trig identities, again, the reason why these are identities is because they work regardless of how big the angle is, how small the angle is, whether it's in degrees, radians, none of that matters. The identities work because they're true regardless. So again, we have 6 reciprocal identities, meaning you flip one, you get that particular trig function. The quotient identities, tangent equals sine over cosine, cotangent equals cosine over sine. And the Pythagorean theorem identity. So again, they're Pythagorean because they're based off of the Pythagorean theorem. So sine squared plus cosine squared equals 1, tangent squared plus 1 equals secant squared, and cotangent squared plus 1 equals cosecant squared. Again, the main purpose for the properties is to be able to algebraically evaluate, manipulate equations, and the such. Most of that comes in pre-calc honors. We're just focused on the evaluation part of this work. So we started with a right triangle last time and put to use the properties before finally looking at it the way that we are going to examine them. You're given one trig function and you're asked to use the properties to get other trig values. So examples 2 and 3, we were given cotangent and sine respectively, and we went ahead and we evaluated the rest of the problem. So our last example that we're going to look at involves tangent theta equal to 2, and we're going to evaluate each expression. So starting with secant. So tangent square, you have tangent theta equal to 2, and you're looking for secant. So the main objective is for you to use a property that has tangent and secant in it. And we just so happen to have tangent squared theta plus 1 equals secant squared theta. So we have one readily available and ready to go. So since tangent is 2, so that means 2 squared plus 1 equals secant squared theta. So 2 squared is 4. And 4 plus 1, 5. So remember, we need secant theta, not secant squared theta. So we can algebraically manipulate that by taking the square root on both sides. So square root of 5 is equal to secant theta. So we leave it as square root of 5. We do not do any other algebra. We do not change that to a decimal. We're leaving it in what's called an exact value. So there's secant. Now, to get cosine, since we know what secant is equal to, we can get cosine very, very easily. So remember that cosine of theta is equal to 1 over secant theta. We just so happen to know what secant theta is. So cosine theta is equal to 1 over square root of 5. Of course, we can't leave the square root at the bottom of the fraction. So multiply the top and the bottom by the square root of 5. Apologize for the interference to the board. So square root of 5 over square root of 25. 5 times 5 is 25. So square root 5 over 5. And that's equal to your cosine theta. So last but not least, we have to find sine. So as I mentioned when we started this on Thursday, there are multiple ways to solve these particular problems, depending on what you have. So There are a couple ways that we can use to get sine given what we have. We know cosine and we know tangent. So there's actually two different properties that we could use. Since we know tangent and we know cosine, we can use the property that tangent theta is equal to sine theta over cosine theta. So we could use that property. Since we know what cosine is equal to, we could also use the property sine squared theta plus cosine squared theta equals 1. So in both cases, we have a couple of options that we can use. So let's first use tangent and cosine. So tangent is 2. Sine we don't know. Cosine is square root 5 over 5. So of course, we don't want the square root sitting out. Well, we don't want this in the denominator. That, and for all intents and purposes, you're dividing by a number. So to divide by a number, to get rid of it, you need to multiply both sides by square root 5 over 5. So if we do that, we're left with sine theta on the right-hand side. On the left-hand side, we have 2 square root 5 over 5. That's that. Problem's over. So technically, you've already simplified it to what you needed to do. If you wanted to solve this out using the cosine value, it more or less amounts to doing the same thing, and you should end up with the same answer. You may have to do a little bit of algebraic manipulation, but you should end up with the exact same thing. So just so you know, there are multiple properties that you can use to solve out the problem. It's just simply pick which one that you can comfortably work with. So with that being said, that concludes section 13.1, and thus concludes our unit on trig. So, of course, on Tuesday, that's our review day. Thursday is your final unit test covering just trig. So let's make this last week work well for us. Have a great rest of your day, and I will talk to you soon.